In Chapter 8, we began our study of statistical inference. We described how we could select a random sample and from this sample estimate the value of a population parameter. Then in Chapter 9, we continued with our study of statistical inference by developing a confidence interval. In this chapter, which is the last chapter we will get to in this course, we are going to focus on statistical hypothesis testing procedures. We consider tests involving one population in this chapter. In this chapter, we're going to learn the 5-step hypothesis testing procedure, understand the difference between a one-tailed and a two-tailed test of hypothesis, and apply this concept to a population mean or proportion. We will also study the two types of errors in hypothesis testing, as well as learn how to compute and interpret a p-value as it relates to the type 1 error. A hypothesis is defined as a statement about a value of a population parameter developed for the purpose of testing. A hypothesis is also a theory, or a claim, or a statement. Hypothesis testing is a procedure based on sample evidence, while probability theory is used to determine whether the hypothesis is a reasonable statement. In statistical hypothesis testing, we normally follow a 5-step procedure. The first step is to state the hypothesis being tested. It is called the null hypothesis and is designated as H sub 0. The capital letter H stands for hypothesis, and the subscript 0 implies no difference. Later in this chapter, we will explore in more detail how to set up the null hypothesis. The second step in hypothesis testing involves the selection of a level of significance. The level of significance is a probability of rejecting the null hypothesis when it is true. In step 3, we identify the test statistic that we will use to test the null hypothesis. Step 4 involves the formulation of a decision rule using the significance level identified in step 2 and the test statistic chosen in step 3. Finally, in step 5, we take a sample, and based on the sample, we compute a statistic, which is then compared to a critical statistic given the significance level identified in step 2, using the decision rule formulated in step 4. At the end of step 5, we conclude either to reject the null hypothesis or not to reject the null hypothesis. And we will go through this in detail so that you understand exactly how to do all of these steps. In hypothesis testing, there are always two pairs of hypotheses known as the null hypothesis, designated as H sub 0, and the alternate hypothesis, designated as H sub 1. The null and alternate hypotheses are mutually exclusive, meaning that only one or the other is true, and they also are collectively exhaustive. The null hypothesis is presumed to be true, while the alternate hypothesis has the burden of proof. A sample is used to test the null hypothesis. If a hypothesis test results in the failure to reject the null hypothesis, this does not necessarily mean that the null hypothesis is true. It only suggests that there is not enough evidence to reject the null hypothesis. In setting up hypotheses, try to watch for keywords in the problem statement, as they will guide you whether the test is two-tailed or one-tailed, either left or right-tailed. Keep in mind also that the alternate hypothesis will always have either the not equal to, the greater than, or the less than symbol. Also keep in mind that the null hypothesis will have the equal sign as in greater than or equal to, less than or equal to, and equal to. In any kind of hypothesis testing, because conclusions about populations are based on samples, there are 3 possible outcomes. 1, the test yields a correct conclusion, that is, we reject a false null hypothesis, or not reject a true null hypothesis. Either of these conclusions is what we want to obtain, as they are correct conclusions. 2, we conclude to reject a true null hypothesis. This is an incorrect conclusion. This is known as the type 1 or alpha error. And 3, we do not reject a false null hypothesis. This is known as the type 2 or beta error. Obviously, we want to minimize the probability of committing either a type 1 or type 2 error. Unfortunately, for a given sample size, we cannot reduce both errors at the same time. Reducing one means increasing the other. So if we want to reduce these errors simultaneously, we need a larger sample size.